Hello, Mr. Betts here. I want to take a look at a few antiderivatives that we can use integration by parts for, but it's not obvious that it would be an integration by parts problem. So remember, integration by parts undoes the product rule. So the formula comes from the product rule, and it's essentially the reverse of the derivative product rule. And this expression right here is definitely not a product, except that it is a product because it's arc sine of x times dx. So if we're thinking about how we would use integration by parts here, remember we want to choose a u so that when we take the derivative, it doesn't get more complicated. And we want to choose a dv so that when we take the antiderivative, it doesn't get more complicated. And remember, one other thing I mentioned with making our choices is that if we have something that we don't know the antiderivative of, like arc sine, that's going to have to be our u. So I'm going to make u equal arc sine of x, which is something we know the derivative of. And then what's left, which is just the dx, is going to become my dv. So using integration by parts, I'm going to take the derivative. So du is going to be 1 over square root of 1 minus x squared dx, and v is just going to be x. So we're going to multiply arc sine of x times x, so it's x arc sine of x minus the antiderivative of v du, so x over the square root of 1 minus x squared dx. Now that is something that we can evaluate using substitution. So notice that the inside of the square root here is going to have a second degree term in it, and the derivative of that is then going to have a first degree term in it, which we can use substitution for the numerator. So if I say u equals 1 minus x squared and du equals negative 2x dx, that gives us dx is equal to du over negative 2x. Then making a substitution there, we're going to have x in the top still for now over the square root of u, and then dx becomes du over negative 2x, and those x's are going to cancel each other out, the negatives cancel each other out, and that 2 is going to go out front, make it a 1/2. And so what we have with that part of the expression is the antiderivative of u to the negative 1/2. That can be evaluated using the power rule. So it's going to be u to the 1/2 divided by 1/2, or times 2, which cancels out the 1/2 here, and plus c because we just took that antiderivative. So then the last step is to re-substitute for u. So we have x arc sine of x plus the square root of 1 minus x squared plus c. And you may remember that I mentioned before that the antiderivative of arc sine is something we can do, but it's complicated. Well, this is the complicated antiderivative of arc sine. We get that antiderivative using integration by parts, even though it's not in a form that we typically use integration by parts for. So I want to look at two more that are like that, and I'm going to go through these fairly quickly. So in this case, I'm going to say u equals arctangent of x because we don't know that antiderivative, and that means that dv is just dx. That means du is 1 over 1 plus x squared dx, and v is equal to x. So making the substitution, we're going to have x times arctangent of x minus the antiderivative of x over 1 plus x squared dx. It's supposed to be an x on top. So just like we saw with arc sine, we can do a substitution here and say u equals 1 plus x squared du equals 2x dx, and dx is equal to du over 2x. I do want to point out here that I chose a u here and I chose a u here that are not equal to each other, and I'm using them in the same problem. Not the best practice. Might have been better if I had said this was v here, something like that. Generally, it's okay. Actually, v would be bad because I used v over here. It is okay as long as it's clear, although technically not the best thing to do. So making the substitution here, the x's, I'm gonna do some of the canceling here when I substitute. So the x's are canceling each other out. That 2 is going to go out front, and so we get antiderivative of 1 over u du. And that one's going to involve the natural log. So we're going to have x arctangent of x minus 1/2 natural log of the absolute value of u plus c. And then we need to replace the u with x's. So minus 1/2 natural log. Now I want to point out that u is 1 plus x squared. 1 plus x squared can't be any less than 1. So the absolute values are not necessary when we put the x's in there. Wouldn't be wrong to have them. It's not necessary. So I'm going to leave them off. We do need the parentheses anyway, so absolute values might even be easier to write. But this would be the simplest expression for that. Last one I want to do is the natural log. This is another antiderivative that we don't know. So I'm going to let u equal the natural log of y, and that means that dv is going to equal dy. So du is going to be 1 over y dy, and v is equal to y. So this is going to equal y times the natural log of y minus the antiderivative of, so y times 1 over y dy is just dy. And so this is going to be y times the natural log of y minus, so this is a 1 in here, so that's just going to be minus y plus c. So the antiderivative of natural log is going to be y times the natural log minus y plus c. This is another one that it's not obvious that we would use integration by parts, but it does work, and it allows us to take an antiderivative essentially by taking the derivative of what we're taking the antiderivative of. I also want to point out, I've mentioned this several times before, if you want to confirm an antiderivative, it's not a bad idea to take the derivative of this and make sure that we get our integrand here to start with.